Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to our presentation for the energy efficiency competition. We will talk about water desalination using sustainable energy. In our case study, we divided it to two parts: simulation parameters and the actual case study. Our parameters are the operation hours, PV brands, control strategies, DG power, tracking systems, and battery type. To desalinate 250 cubic meters of water, we need 15 kilowatts of load. And we chose a generic PV that has an efficiency of 13%, a control strategy of load following, a diesel generator of 10 kilowatts, no tracking system, and a battery of generic lithium ion. The results of the simulation for 25 years, which is the lifetime of a PV, showed a cost of $441,000 and a renewable fraction of 63.1%. Now we change the model to 12 hours only, which requires doubling the load to 29.5 kilowatts. The result showed a cost of $500,000 and 92% renewable fraction. Now we will experiment if 25 kilowatt diesel generator is better than 10 or not. So we can see that the result showed 271,000, which is almost half the price or half the cost, and the renewable fraction of 77.9, which is a significant drop. So we will not use the 25 kilowatt generator. For the tracking system comparison, we can go with no tracking or with adjustment of monthly, weekly, daily, or continuously. We can see from the charts that the no tracking option is the lowest in cost, and the continuous adjustment is the highest in renewable fraction. So we will pick this. So we'll pick the continuous adjustment. For the control strategies, there are 4 types: the load following, cycle charging, combined dispatch, and predicted. We can see from the chart that the predictive control has the lowest cost and the highest renewable fraction. Moving to PV brand comparison, we started with the generic PV and we compared LG, Panasonic, SunPower, Jinko, and Qcells. And the result showed that Jinko has the lowest cost and the highest renewable fraction. Moving on to battery types comparison, we started with generic lithium ion and we are comparing it to VRLA, lead acid, lithium ion from Huawei, zinc bromide, and redox flow. We can see from the chart that the zinc bromide has the lowest cost and the highest renewable fraction. The starting model and our green model, we can see that the cost went from 441,000 to 75,000 only, and the renewable fraction from 63% to 100%. For the second part, applying what we've learned so far to KFUPM's desalination station, currently it's powered using grid, which would cost 3.2 million for 25 years, and a renewable fraction of 0%. Using our PV system, the cost would go low to 1.6 million and 100% renewable fraction. And if we combine the grid and our PV system, the cost would go slightly lower and the renewable fraction also slightly lower. but this option is preferable since it's more stable. Thank you for listening, and that was our presentation.